What's up, everybody, and welcome back to Algebra and Trigonometry, Chapter 1, Section 5, Factoring Polynomials. Let's do it. If the terms of a polynomial do not have a GCF, does that mean it is not factorable? Explain. So this is definitely not the case, and I'll give you a quick example. So with 4x squared minus 9y squared, this is actually a difference of squares, and this is actually factorable even though there's no GCF. And again, GCF is the greatest common factor, so they have nothing in common that can be factored out, but this can be factored as follows. We could have 2x minus 3y times 2x plus 3y. So in short, it does not need a GCF. How do you factor by grouping? So in this text, when they talk about factoring by grouping, it has a slightly different definition than the one I'm accustomed to seeing. So I'm going to kind of show you both ways, but here they generally mean just how do you factor a trinomial. So I'm going to show you how to do that by an example. So for example, we have x squared minus 6x plus 8. So when I factor by grouping, first what I'm going to do is I'm going to split it into two groups like so. And since I see x squared here, that's going to be the product of the first two terms in these parentheses. So that's going to be x and x. Then what I do is I say, all right, what two numbers are going to multiply to 8 and add to negative 6? Now just note, not every trinomial is going to be factorable, but this one is. So we do have two magic numbers that multiply to positive 8 and add to negative 6. That's going to be negative 2 and negative 4, and that's the process. The more traditional way that we think about the term factor by grouping is when we have a four-term polynomial. So I'm going to show you what that looks like. So let's say we've got x cubed minus 4x plus 12x minus 48. What we're going to do in this sense is we're going to section these off like so. Then we're going to factor out a GCF out of each binomial. So now I got x cubed minus 4x squared plus 12x minus 48. And then what I'm going to do is I'm going to section these off into two binomials and factor out the respective GCF. So for example, here I've got an x squared in common for both terms. So I'm going to factor out an x squared. And I've got x minus 4 like this. Here I'm going to factor out a 12, and I've got x minus 4 inside. The reason why, if I redistribute this, I would get x cubed and negative 4x squared. If I redistributed the 12, I get 12x minus 48. Then they both have an x minus 4 in common, so I'm going to factor that out, and I'm going to have x minus 4. And then what's left in this new binomial is that x squared there and the 12 there. Now the last possibility is when we have a coefficient in front of that leading term. So we're going to have to do something a little bit differently. So the way that I like to do this is using something called the star method. So when we have the star method, what you do is you take this a term. I'm going to say that's a, that's b, that's c. I'm going to take that a term, place it up here like so. I'm going to place the a times c, which is 3 times negative 14, which is negative 42. I'm going to place it up top. And then that b, there's an invisible 1 there, so I'm going to place a 1 down here. Then I'm going to ask the question, what two numbers multiply to negative 42 and add to 1? And that would be positive 7 and negative 6. Then I'm going to take these two terms on top of each other, reduce them like a ratio, and I can divide them both by 3. So I've got 1 and I've got negative 2. Then this comprises one binomial, this comprises the other. So then it factors to 3x plus 7 times x, 1x, minus 2. Here we're finding the greatest common factor of the entire expression. So we're going to look at each coefficient first and see what's the GCF of those coefficients. Well, the largest number that all three of them can be divided by is 7. So I'm going to pull out a 7. And then when I look at the m's, we've got an m squared, and m. So the greatest that's in common for all three is just a single m. And then when it comes to the b's and the a's, the issue is this one has b's but no a. This one has both, and this one has a squared but no b, which means that the three of them do not share any a's or b's all in common, which means 7m is the GCF. Boom, done. So again, finding the GCF, first I'm going to look at the coefficient. So what's the GCF for the greatest common factor of 200, 30, and 40? It's going to be 10. And a nice little rule is when I look at two numbers or three numbers, I'm trying to find the GCF will never be bigger than the smallest difference between two numbers. So I know that 30 and 40 have a difference of 10. That's the max it can be. And since 10 is a factor of 200, we know 10 is the GCF of the coefficients. Now when we come to the variables, we see p here and here, but not here. So p is not going to be part of the greatest common factor of all three. But we do have m cubed in all three. So that is the GCF. Boom, done. So first, when I look at the coefficients, I've got a 6, a 2, a 3, and a 1. I don't see anything in common with those except for a 1, so there's no coefficient GCF. Then when we talk about the y's, I've got y to the fourth, y cubed, y squared, and a y. So they all have a single y in common, which means y is the GCF. Done. So again, here we're going to factor by grouping. So first I'm going to make note of the A, B, and C. A is 2, B is 9, C is negative 18. Then I'm going to draw this out, my star method here. I'm going to place the A's up top like so. A times C, 2 times negative 18, negative 36 over here. And the B on the bottom as 9. Then I asked the question, what two numbers multiply to negative 36 and add to 9? That is, of course, 12 and negative 3. Then I'm going to reduce these if possible. I can reduce the 2 and the 12, divide them both by 2, and I've got 1 and 6. Now I've got binomial 1 and binomial 2, and the top number is going to be paired with the variable. So now it's going to look like 2a minus 3 times 1a, or just a, plus 6. And by the way, the ordering of these binomials, it doesn't matter. You could put a plus 6 first or second. So this is the winner. Done. Once again, we got A, B, and C, and we're going to place a star like this, and I'm going to place the A's here, A times C, negative 66 up top, and negative 19 on the bottom. Now you have the question, what two numbers multiply to negative 66 and add to negative 19? That's going to be negative 22 and positive 3. Multiplies to negative 66, adds to negative 19. Then I'm going to reduce the top and the bottom like so, as if they were fractions. So I'm going to divide these both by 3, and I get 2 and 1. I'm going to divide these both by 2, and I get 3 and negative 11. So here are the binomials that will be in factored form. So again, the top part goes with the variable. So I've got 2n plus 1 times 3n minus 11. Boom, done. Once again, we got a leading coefficient, so we're going to use the star method. So we're going to set it up like this. I've got A, B, and C. Up here, we've got the A's, 2 and 2. On the top, we've got A times C, 2 times negative 7, which is negative 14, and that negative 5B on the bottom. So what two numbers multiply to negative 14, add to negative 5? That would be negative 7 and positive 2. Then we're going to reduce this side. We can divide both by 2. So we got 1 and 1. And now we've got our two binomials. Again, the top pairs with the variable. So we've got 2p minus 7 times 1p, or p plus 1. Boom, done. Once again, we've got A, B, and C, and we're going to use our star method. We've got the A's up here, 10 and 10. We've got the A times C, 10 times negative 9, which is negative 90. And down here we got the B, which is negative 9. So what two numbers multiply to negative 90, add to negative 9? So the answer would be negative 15 and positive 6. They multiply to negative 90, add to negative 9. So now I'm going to reduce these like so. 10 over 6 can be divided by 2 and 2. So it becomes 5 and 3. 10 and 15 can both be divided by 5. So we have 2 and negative 3. And these are the binomials. So now I have the top part pairs with the variable, so I've got 2h minus 3 times 5h plus 3. Boom, done. So we've got our A, B, and C terms identified. Once again, we're going to create our star. But the A is up here, 9 and 9. A times C, 9 times 8 is 72. And that B, negative 73, down here. So what two numbers multiply to positive 72 and add to negative 73? This one is going to be negative 72 and negative 1. Multiply to positive 72, add to negative 73. Then we're going to reduce. We're going to divide these two by 9. So we get 1 and negative 8. And here are our two binomials. So we've got 1d, or just d, minus 8 times 9d minus 1. Boom, done. Here we've got our A, B, and C terms. And by the way, that B is an invisible 1. So now we're going to set up our star system. A goes up here and here. A times C goes here. That's negative 156. And the B term, the 1, goes down here. So what two numbers multiply to negative 156 add to 1? Well, that's going to be positive 13 and negative 12. Then we're going to simplify by dividing both of these by 12, and we've got 1 and -1. And now we've got the setup for our two binomials. So here we have 12 times the variable t plus 13, and here we have 1t, or just t minus 1, boom, done. This binomial here is actually a difference of squares, and we know that because there's a subtraction, and both of these are perfect squares. So to factor this correctly, all we got to do is take the square root of the first term. The square root of 16 is 4, the square root of x squared is x, and we place that here and here. And then what's the square root of 100? That's 10. We place that here and here. And then we alternate plus, minus, and that's how you factor a difference of squares. Once again, here we have a difference of squares. These are both perfect squares. So to factor, we're going to take the square root of the first term. Square root of 121 is 11. Square root of p squared is p. And we're going to place that here and here. Then we're going to take the square root of 169, which is 13, and place that there and there. And then we're going to alternate plus, minus, boom, done. With a difference of squares here, we've got a perfect square minus a perfect square. So we just got to have a good understanding of your perfect square. So the square root of 361, that first term, is actually 19. Square root of d squared is d, so we place that here and here. Square root of 81 is 9, so we place that here and here, and then we alternate plus, minus. By the way, it could be minus plus as well, same difference, boom, done. Here we got a difference of squares again, so we take the square root of that first term, 144b squared. Square root of 144 is 12. Square root of b squared is b, so we place that here and here. Square root of 25 is 5. Square root of c squared is c. So we have a 5 and a c, alternate with plus and minus, boom, done. So in this question, the numbers are relatively large, and if we use the star method, it would be a little bit trickier than normal. But instead, what we can recognize nicely is that these are both perfect squares. So this might very well be a perfect square trinomial. The way you factor a perfect square trinomial is you basically take the square root of that first number, 7n, right? Square root of 49 is 7, square root of n squared is n. Place that there. The square root of 144 is, of course, 12. The main thing is we got to make sure that it works with this middle term. So since it's all plus, these are going to be plus as well. And 7 times 12 is 84. Same here. 84 plus 84 does indeed add up to 168n, which means we factored it correctly. And since it's a repeat of the same binomial, we can write this as 7n plus 12 squared, boom, done. Once again, we have what looks like a perfect square trinomial because we've got a perfect square here and here. So what I'm going to do is I'm going to factor it as such. I'm going to take the square root of 225y squared as 15y, like so, and the square root of 4 and the square root of 16, which is 4, and place that here and here. And now we're just going to verify to make sure that that middle term works out as we think. So that becomes 60, and that becomes 60, which gives us the 120. So once again, we can rewrite this as follows, as 15y plus 4 squared, since we have a repeated binomial, boom, done. Once again, we have what looks like a perfect square trinomial, so I'm going to set it up assuming that is the case. We take the square root of 25p squared, which is a nice 5p, like so, and the square root of 144, perfect square, that is 12. Now here I see a minus, and here this is positive, which means that we're going to have minuses for both, because negative 12 times negative 12 is positive 144, and then these terms here will be negative. And check it out, 5p times negative 12 is negative 60p. This is negative 60p as well. They would add to negative 120p. Last but not least, it's a binomial repeated, so I can condense it to be 5p minus 12 squared, boom, done. Here we've got a sum of cubes. So how do we factor a sum of cubes? So a nice thing I like to remember is same, different, plus. So in this case, let's pretend we have a cubed plus b cubed. That would factor to be like so, same, which is a plus b. So what are we doing? We're taking the cube root of each. So we're saying a plus b, that's the same. Then we've got a squared over here. And then when we say different, same, different. So if it starts as plus, we have a minus. So this next connector or this next arithmetic symbol is going to be the opposite of what's here. So same, different, and then we have a, b, and then we have plus. It's always plus for the third one, b squared. And this is your basic setup. So now we can apply this to this binomial here, and we can factor it as follows. So we have x plus the cube root of 216 is actually 6 times a squared, that would be x squared in this case, minus 6 times x, or a times b, so we'll say 6x, so we like to put the number first, and then plus this term, the b term squared, which is 36, and this is not going to be factorable anymore when we do a sum of cubes or a difference of cubes, so we are done. So once again, we have what looks like a sum of cubes, so I'm going to put up that formula again. We take a cubed plus b cubed, it's the same as same, which is the cube root of this plus this, a plus b, and then times a squared, and then we say same, different, plus. Same is the plus, different is a minus, because that's plus can be minus, then it's a times b, and then plus, it's always plus at the end, plus that b squared. So this is the format, so let's apply it here. So first we've got the cube root of 125, a cubed, that's 5a, cube root of 343, that is of course 7. So now we multiply against what's going to be this trinomial. So first we have the a squared, 5a squared is 25a squared, minus a times b, 5a times 7, which is 35a. And then finally we have plus b squared is 7 squared, which is 49. Boom, done. Here we have a difference of cubes, so I'm going to show you how this looks. And again, we go back to that idea of same, different, plus. It works for sum and difference of cubes, so check it out. First we have same, so I again take a and b, and since subtraction is what's happening here, same. Then we have, again, a squared, like before, like in the sum of cubes, but then we have same, different, so what's different than minus, plus, and then we have a times b, and then we have same, different, plus, so the last connector, the last arithmetic symbol is plus b squared, so b squared goes here. Now let's apply it. Again, this is a cubed, this is b cubed. So what is a? A is the cube root of 64x cubed. Cube root of 64 is 4, cube root of x cubed is x, and then we have minus b. So the b cube root of 125 is 5. And now we go to the trinomial a squared, that's 4x squared, which is 16x squared, plus a times b, 4x times 5, which is 20x, and then plus b squared, 5 squared is 25 for the win. Boom, done. Once again, we have a sum of cubes. For a sum of cubes, just as a refresh, it is a plus b, same, times a squared, different, so it's minus ab plus b squared, and we're going to show you how this applies. So again, 125r cubed, that's a perfect cube, as it should be to do a sum of cubes. Cube root of 125 is 5, cube root of r cubed is r, plus the cube root of 1728 is actually 12, cube root of s cubed is s. And then so we have same, the plus, times a squared, 5r is a, so that's 25r squared when you square it, minus, right, a times b, 5 times 12 is 60, and don't forget the r, s, and then last but not least, plus b squared plus 12s squared, which is 144, s squared, boom, done. For these types of problems, what you want to do is you want to look at the common binomials. And what you want to factor out is you want to factor out whichever one has the lower exponent. So for example here, I'm going to factor out 2c plus 3 to the negative 1/4. Then what I'm going to have left inside is I'm going to have just a nice 3c, and then I'm going to have minus 5 times what? So the question is, when we redistribute this 2c plus 3 to the negative 1/4 and multiply it here, we should come back to this term. So the main idea is that, and these are going to be set up nicely so it works out like this. The main idea is we're going to have 2c plus 3 to the first power here. So why is that? When I redistribute this, think about it, it's going to be the same binomial and the exponents are going to add. So negative 1/4 plus 1 gives me that positive 3/4. Again, these are very special types of polynomial expressions. It's going to work out nicely like this if you remember the general step of just, hey, I'm going to pull out the smaller exponent. Now I can simplify what's inside by first distributing the negative 5. So then I have 3c minus 10c minus 15. Then I'm going to combine these. 3c minus 10c is negative 7c minus 15. And then this is going to still be multiplied by that original binomial, 2c plus 3 to the negative 1/4. And this is the final factored form. Done. Once again, we're going to follow that same protocol. We're going to look at these two expressions and say which one has a lower exponent, rational exponent. It's going to be that negative 2/5. So I'm going to factor out x plus 2 to the negative 2/5. And when I factor it out of the first term, just that 14x is left over. When I factor it out of this one, this is where it gets interesting. Think about it. So I'm still going to have 5 times x plus 2. But the way we want to imagine what the remaining exponent is when we redistribute, if we were to redistribute, we should come back to x plus 2 to the 3/5, which means it begs the question, what plus negative 2/5 gives me 3/5? Well, that's just going to be 1. And look how nicely that works out, because I don't even need to write that 1. Now I can simplify what's in here by distributing the 5 to those two terms. And then I have 14x plus 5x plus 10 combined like terms, and I have 19x plus 10. And then out here, we have x plus 2 to the negative 2/5 for the win. Done. Once again, we've got 2z minus 9 and 2z minus 9, so we're going to follow the same protocol as before. We're going to factor out the binomial with the lower exponent. So I'm going to factor out a 2z minus 9 to the negative 3/2, and everything's going to fall into place. So left inside of this first expression, when I factor out this 2z minus 9 to the negative 3/2, I just have 5z left over. Then over here, I have 11, and I still have this binomial here, 2z minus 9. But imagine if we were to redistribute this, we'd need to come back to negative 1/2. So that begs the question, negative 3/2 plus what? Because when we multiply two binomials or to anything that are the same with exponents, we add the exponents. So the question is negative 3/2 plus what brings me back to negative 1/2? Well, it's just 1. And that's what we want, because I don't even have to write that 1. And now I can distribute this 11 like so. So now I have 2z minus 9 to the negative 3/2. And then inside here, I have 5z plus 11 times 2 is 22z minus 99. Now I can combine these guys, and I get 27z minus 99. And that first binomial is still there. So we still have 2z minus 9 to the negative 3/2. Boom, done. So for this question, we're given an expression of length times width, aka the area. So they want us to find the actual length and the width by factoring this expression. So what I'm going to do to factor this is I'm going to look at all the possible factors of the product of these two, but I'm going to look at it as prime factors. So for example, 98 is 2 times 7 times 7. 27 is 3 times 3 times 3. And again, remembering that this is a negative 27, this is going to be a negative. So what I'm going to do is I'm going to want to have one negative value and one positive value that is going to add to 105. So if I group 2, 7, 3, and 3, I get 126. And then if I group 7 and 3, I get a negative 21. So I'm choosing to place the negative with this 7. So now watch as we do this. We get 98x squared plus 126x minus 21x minus 27. And see, again, these combine back to the 105. So I haven't really changed much. I'm just changing the distribution based on the prime factors of 98 times negative 27. Then I'm going to pair these off and pair these off. And I'm going to factor out GCF. So my GCF of 98x squared and 126x is 14x. And I'm left here with 7x plus 9. And then out here, I can factor out a negative 3. And I'm left with positive 7x plus 9. And that's the key. Now we have 7x plus 9, 7x plus 9 in both. Finally, I'm going to yank out the 7x plus 9 as it's common to both. And then what's left inside is that 14x and that minus 3. So now we can arbitrarily say this is the length and this is the width, or vice versa. Boom, done. At the northwest corner of the park, the city is going to install a fountain. The area of the base of the fountain is 9x squared minus 25m squared. Factor the area to find the lengths of the sides of the fountain. So in this case, we again have a difference of squares, and I believe that's meters squared, so that's not part of the binomial. So we have 9x squared minus 25. To factor a difference of squares, we take the square root of the first term, which is square root of 9 is 3, square root of x squared is x. Place that here and here. Square root of 25 is 5 and 5, and then we alternate plus minus. So we could arbitrarily say that this could be the length, and this could be the width, or vice versa. Boom, done. The following exercises factor the polynomials completely. So in this case, I'm guessing that this is going to be a nice perfect square trinomial because I got a perfect square here and a perfect square here. We're going to try it out, and it's likely going to work to get us that middle term, but we need to check. So I'm going to first start by placing the square root of 16x to the fourth. That's going to be square root of 16 is 4. Square root of x to the fourth is x squared. That's going to go here and here. What about 625? I know that one, and that is a square root of 25. So 625 is 25 squared. And then we're going to need minuses for both because we have a minus here and a plus here. Negative 25 times negative 25 is positive 625. Now to double check, we have 4 times 25, which is negative 100. Negative 25 times 4, which is negative 100. That does indeed add to negative 200x squared. Now we could combine this to become 4x squared minus 25 squared. But guess what we see here? We see another difference of squares within these binomials. So I can factor that again. So the 4x squared minus 25 can be 2x and 2x, right? The square root of 4x squared. And then 5 and 5, but a difference of squares would be plus minus. And this is going to be the same thing. 2x plus 5 times 2x minus 5. Last but not least, we can kind of merge these together. That's a binomial times itself, 2x plus 5 squared. And then we can merge these, 2x minus 5 squared for the win. Done. Here we have a difference of squares, so 16z to the fourth, so let's factor that first. Square root of 16z to the fourth is 4z squared, and I'm going to place that here and here. The square root of 2,401 is actually 49, and I'll show you quickly why that is. So we do 9 times 9 is 81, carry the 8, 36 plus 8 is 44, 0. 4 times 9 is 36, carry the 3, 16 plus 3 is 19, and we get 1, carry the 1, 14, carry the 1, and 2. So we place the 49 here and here, but don't forget it's a to the fourth, so that becomes a squared. And since it's a difference of squares, we alternate plus, minus. But then we got another difference of squares. These are both perfect squares, so check this out. I'm going to factor this as 2z and 2z. What's square root of 49? 7. Don't forget the a. 7a. Alternate with the plus, minus. And then this one stays as is out here. We got 4z squared plus 49a squared for the win. Boom, done. So first of all, what does this negative exponent mean? It means that everything is going to be under 1. So let's start there. We got 32x cubed plus 48x squared minus 162x minus 243. Now this is a prime example of where we want to use factoring by grouping because we've actually got 4 terms. So what I'm going to do is I'm going to group these guys and I'm going to group these guys like so. Then I'm going to factor out a GCF of that first binomial. So both of these terms can be divided by 16 and we got an x squared in common. So what's left inside is 32 divided by 16 is 2x plus 3 because 3 times 16 gives us that 48x squared. And then I'm going to factor out a negative 81 from these guys. And if I factor out a negative 81, 2 times negative 81 gives me negative 162. But don't forget that x has to stay inside. And then 3 times negative 81 is negative 243. And this is what we want. We want matching binomials here and here. So next I'm going to factor out the 2x plus 3 like so. So we have a 2x plus 3 comes out. And then what stays inside is that 16x squared minus 81. And what you'll notice now is we have another difference of squares, of perfect squares, so we can factor one more time. So we've got 1 over 2x plus 3. And then to factor this, we have the square root of 16, which is 4x, like so. And then we take the square root of 81, which is 9. And since it's a difference of squares, we alternate plus, minus, boom, done. I hope you enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.